Hello, class. This will be the recorded lecture starting in chapter 6 now. And chapter 6 deals with a few more algebraic concepts. And then it introduces the functions of exponential and logarithmic. So before we get to those, we're going to talk about a few more algebraic ideas. And the first one is called composition of functions. And basically, that way to think about that is a function kind of operation. And an operation like on numbers of addition, subtraction, multiplication, divisions, or operations, composition is like an operation. And basically, what it is that you take one function and you kind of integrate it into another function. And then we're going to decompose functions as well. You'll need that more in calculus than you will in algebra. So we won't spend too much time on the first part, but we're going to spend some time on this idea of composition of two functions. And the way that we describe it is such, is that sometimes you use this little open circle in between these two letters that are describing functions, and that means composition. I like the second way better because it indicates actually what is actually happening, where this would be the second way, f parentheses g parentheses of x. And the way to think about that is this little figure here, which I think is nice. So the input of x goes into the first function g, and then out will come some other either number or other expression, and that expression goes into function f. And so you kind of just walk through it. It's kind of a step-by-step style process. And let's go through a couple examples. I think that would be good. So why don't we do this one here? And I'll do this one up on the whiteboard. So say like we had this equation, f of x equals 3x minus 1, and g of x equals x squared plus x minus 3. So there's a variety of different ways that things that you could do. First one would be something like this, f of g of, say, just the number 2. So you're physically going to get a output that is a number as well. So if your input's a number to a function, your output's a number to a function, right? And so how do you do this? Well, the first thing you do is you do what's inside the parentheses, just like you do. So you're going to plug in the value 2 in for g. And so that would be 2 squared plus 2 minus 3. And so that would be 4 plus 2 minus 3. That looks like that's 6 minus 3. So that would be 3. So now this looks like this, right? Because if f of 2 equals 3, then you plug 3 in for f, and you would get 3 times 3 minus 1, and that would be 6 minus 1 equals 5. Hopefully not too bad. It's interesting, though, that say like you did it the other way. So say like we put the g and then f of 2. Well, you do the same thing, but the first thing you do now is put 2 in for f, and you would get, whoops, you know what, I screwed up here. 3 times 3 is not 6, it's 9. Sorry about that. So the answer would be 8. Maybe I should look at my notes. When I look down at my notes, I'm like, how did I not get 8, right? And so that's because 3 times 3 is not 6, but 3 times 3 is 9. But anyways, back to this one here. That's why it's good to show your work, because I saw exactly where I made my mistake. And so this is 6 minus 1 equals 5. And so now this 5 would replace the f of 2, and that's what you plug into g. So when we do that, we get 5 squared plus 5 minus 3. So that's 25 plus 5 minus 3, and that would equal 27. So it's interesting that you see that these two numbers are not the same. And most of the time they're not going to be. And we'll talk about the criteria that you need for those to be the same, I think in the next section. So just kind of introduce this concept. Well, one of the other things that we're going to talk about is instead of just plugging in numbers, we would plug in, for example, what would be f of g of just regular old x. So this would be a composition of functions now. And so the output is also going to be a function. And so what you will end up getting is g of x is x squared plus x minus 3. So you can think about it this way. So wherever you see x, you got to plug this craziness in. Well, that's not too bad here because we have 3x minus 1. So it would look like this, right? It would be 3, and then we would have x squared plus x minus 3, and then we have the minus 1 outside. And so you distribute the 3 through, you would get 3x squared plus 3x minus 9 minus 1. And you combine those like terms, which is the two constant terms. And you would get plus 10. So say like we went the other way. That one's going to be a little bit harder, right? F or g of f of x. So when we do it that way, you're going to end up having g of 3x minus 1. And so wherever you see x and g, you plug in 3x minus 1. So this would be 3x minus 1 squared plus 3x minus 1 minus 3. So now we have to do a little bit of algebra. So you want to expand that. And if you do that, that would be 9x squared minus 6x plus 1. And then we have plus 3x minus 1 minus 3. So again, let's combine like terms. We have one square term. We have a minus 6 and a plus 3 for the linear term. So that would be, whoops, it's not plus 3, it would be minus 3. So that would be minus 3x. 1 minus 1 cancel, and you're left with minus 3. So again, these two are not the same. And so this is the technique for the composition of functions. So I think I'm going to end the first recording here. And then the next recording, we'll finish this section and talk a little bit more about how to calculate this with another example, and also throw in domains now. Makes it a little bit trickier.